I wish you welcome to this, let's say, after lunch session. During this session, we will hear 4 presentations. So now we will start with the first presentation. The first paper is written by the authors which are coming from Kosovo, from Pristina, and from Croatia, Zagreb. They are Arta Sulejmani, Ivana Banjak-Pečor, and Bojan Milovanović. The title of the paper is Properties and Characteristics of Expanded Polystyrene Insulation and its Use in Buildings. The paper will be presented by Arta Sulejmani. So Arta, please come and present us your paper. The floor is yours.
Thank you very much. Okay. Hi everyone. My name is Arta Sulejmani. I'm PhD student at the University of Zagreb, and today I'm going to present the properties and characteristics of expanded polystyrene insulation and its use in buildings. This work could not be done without the help of Professor Ivana Banjak-Pečor and also Professor Bojan Milovanović, which I would like to express a sincere gratitude to them. This is the structure of the paper. In a few slides, I'm going to present them all by one, so I don't want to overwhelm you with a double information. Okay, this session I would like to start by asking what is the expanded polyestyrene insulation, or EPS as well known. EPS is a key material in building construction with an extraordinary impact in a lot of aspects such as health, quality of life, social well-being, and energy efficiency. When I say energy efficiency, I mean for the building energy performance, because as all of us we know, if the building is properly insulated, that can save the energy for heating and cooling for more than 60%. EPS has a different application. All of us, we know that the application can be found into the food packages, it can be found into the decorative tiles, into the road and also railway construction, and even though nowadays it can find also in the road helmet bikes. Nowadays, application of EPS, it's more than 7 billion kilograms per year in different fields of its use. Research aim is to clarify the performance of the EPS as an insulator, especially application in the building envelope. We will be much more specifically in the mixing of EPS with different other materials, and in the end of the session we will describe much more about the graphite, perforated, and also cutted EPS, which are the best materials from the family of the expanded polystyrene insulation. But first of all, we would like to discuss or to explain much more about the EPS production process. EPS production process goes in 3 stages. The first one are presented the initial phase or raw bead materials. Those raw bead materials have the size of the sugar beads, and if they go under the heat of steam, they can somehow, we have pre-puff beads. Those pre-puff beads have a dimension of 40 to 55 times higher than the raw material. And if those pre-puff beads reaches the temperature and also they pressure, they balance pressure, they put into the large boxes which they dive into the mold, and then they undergo again into the pressure of the heat of the steam, and then we will have the third picture, which is the panels of the EPS. They are presented in different thickness, in different characteristics for the different projects. Of course, EPS insulation, it's a composite of the organic elements such as carbon, hydrogen, and also oxygen. Simple EPS contains 98% of the air. only the rest of the structure, it's polystyrene or the plastic, which means this material is very light in weight. If we compare, for example, with the concrete, we can say that the approximately EPS is 100 times lighter than the concrete. Or if we compare with the same thickness with other different insulation materials, such as, for example, mineral wool, these comparisons go 12 times higher for the mineral wool. Thermal conductivity of the EPS is relatively low. It goes from 0.034 to 0.038 watt per meter Kelvin. And also the density is 10 to 32 kilogram per its volume. In terms of environmental impact, EPS, it is shown as one of the good material in terms of comparing to the other thermal insulation materials. For example, if we compare with a mineral wool in terms of global warming potential, we can say that for the same thickness of thermal insulation, EPS, and also mineral wool is 3 times higher CO2 equivalent emission than the EPS. These values goes to 4 times higher if the thickness of thermal insulation is 25 centimeters. Of course, mineral wool is less environmental friendly, and this is also in terms of use of non-renewable primary energy sources. All of us, we know that the organic materials, especially those polystyrene foams, are flammable. The reason is very simple, because they are 98% of the air. The rest is the plastic. Plastic is flammable. So in the 100 degrees Celsius, the EPS, first of all, started to soften, then it shrinks, and then if we heat up the temperature, we can show that it melts. In that point, when the EPS is melted, it releases the flammable gases. Those flammable gases are hazard toxic, which all of us, we know the impact on our life. So many researches have been done, so many experiments have been done in this regard in order to find fire redundant and also to find the proper or mixing of different materials, different additives in order to solve the issue of the EPS towards the fire process. Application of EPS in construction sector. All of us, we know that it's very used. The reason is very simple, because it's cheap compared to the other thermal insulation materials. It's efficient, it's standard-based, it's high performance, and also it's environmental friendly. For example, we have the second picture, which are presented the SIPS panel or sandwich panel, as all of us we know. The reason why this material is used from 1960 is because it has a double density with low thermal conductivity, which means it has a high performance, energy performance. And also EPS can be found in or can be mixed with other materials, with other additives, but not all the time EPS can be as a main material. Sometimes even the waste of the EPS can be part of the other materials, such as a concrete. If we mix concrete with the waste of EPS, we can take a concrete lightweight EPS, which means that we'll reduce the weight of the main material, such as a concrete, and also will increase the energy performance of this material as a whole. The combination or mixing of the EPS with other materials, of course, can be with other, such as steel, aluminum, fiber, carbon, wooden cellulose, waste, etc. Also, there is another disadvantages of EPS. When it is exposure to the sunlight, it is sensitive, because for every 70 degrees Celsius of differences of temperature, EPS can change its length for 1 millimeter per meter, and vice versa. If the condition or the weather condition are cold, so it can shrink, and we will have this kind of problems into the application of the EPS. But also there are some some solution, for example, of perforation of depth and slice of spacing, even that we can have slightly deformation such as increasing of thermal conductivity and also heat losses, but also this material can be safe and also can be applicable in most of the time in those kind of buildings. And then we came to the graphite perforated and also cutted EPS. As I said in the beginning, I wanted to present also those three materials because they are presented as the most suitable or most favorable in the family of the EPS. The reason why they are very stable in terms of dimensional, they can change less than 2%, even if they are exposed to the high temperature and also into the humidity. Cutted EPS, they are rigid structure, they are closed cell foams, no voids, lightweighted, and also elastic foam. By using CAD systems and also CNC equipment or machinery, we can have a different application of this material, not only in the construction sector, but also in the airspace, aircraft, marine, in transportation, and nowadays we can see that this material is much more used also into the production of the renewable energy sources, especially those with bioenergy wind. Gray expanded polyester, you can see that the EPS has a different color from the white. It has a dark color. The reason why it's very simple, because in the beads of the thermal insulation, they are integrated to graphite. Graphite has a dark color, so this is the reason why it has this color. And this presents one of the insulation with a better ability of the or improvement of the insulation by 20%, more than 20%. The reason is very simple, because the radiant, when the heat is from inside tries to go outside, then heat came to the layer of the EPS boards, and then the radiant heat moves through the whole the graphite insulation, and which reflects 100 times, which means that the heat comes back again into the inside, and this is the reason why we have these boards which are much more suitable and also with a high performance. Also, those panels are lightweighted, easy to cut, high resistant to the mold growth, cost effectiveness, environmental friendly, and also environmental friendly product. And then we have the last material, which is perforated EPS boards. When we design a building, we have to think also about the airtightness of the building, which is one of the crucial appointments in this regard. And then we know that each building envelope elements has to be briefable. When we think about the walls, briefable walls, we think about the perforated EPS boards. What are the perforated EPS boards or open EPS boards? Are the vapor permeability. It's a structure of the paper. It's a structure of the panels with a lot of holes or air pockets in their surface with a diameter 2 to 3 millimeter, which helps to ensure high vapor permeability and enable water vapor to be released in the surface of the building. Here I have presented a table which I wanted to see the comparisons between the perforated EPS boards and also graphite EPS boards. You can see that there are not so many differences, but still perforated EPS boards, it is remain one of the materials in the family of EPS as the best one. As a conclusion, we can see that the application of EPS is worldwide in different fields, especially those in construction. When we mix with the other material, we can see that it decreases the flame and still remain the good thermal insulation material, taking into consideration all the good aspects that we have explained before. We can say that EPS components have a promising prospect in the field of thermal insulation of the building envelope now and also in the future. So this is all by my side. If you have any question, I am to answer here. If you don't have, it's okay. If you have, or if I don't know the question, I will ask ChatGPT. So.
Thank you for giving us the review
Hi, thank you for your presentation. It was nice. Remind me this business that I was involved before 30 years for the expanded polystyrene. But finally, since you're involved in this research, what we have to choose for a building for the thermal insulation? Expanded polystyrene or the typical glass walls?
There is one comparison, as I mentioned here. It's a comparison between polystyrene EPS and also mineral wool, and also the other type of the comparisons with the other thermal insulation materials. I would choose the EPS because in terms of global warming potential, it is seen that it's much more favorable. Before starting to make a research for this paper, I thought that mineral wool is the best for me to choose for insulation of the building. But now when I have made those researches, I saw that there are so many advantages of the expanded polyester compared to the other thermal thickness of the, or different materials for the thermal insulation. So this is the reason why I think that the EPS now it's much more favorable in terms of economic and also in terms of energy efficiency.
Of course, we still remain with a problem in the case of a fire.
Yeah,
in the building.
yeah.
If I
Yeah.
can help, it depends on the utilization of the thermal insulation. If it is used for building, that the type of facade have to be analyzed.
Yeah.
Of course,
And
yes.
also the type of the building, the rise of the building,
Yeah, of course.
and the volume of the
And sometimes the regulation of the,
yes, it
of the
has to
country or
be
the region.
analyzed, and according to the properties, we can choose the appropriate type of the
But if
thermal
we have,
insulation material.
yeah, but if you have to choose between the expanded polystyrene and also other type of thermal insulation material, of course I will choose expanded polystyrene because, as I mentioned before, there are so many advantages, and I
There
think,
are some
yeah,
restrictions
Yeah,
yeah,
right.
for
in
sure.
utilization of style.
Okay,
Yeah,
thank you.
thank you.
Before we go to the next presentation, I would like to ask just a short question.
Sorry.
Do you plan to do some experimental analysis of this type of, in the framework of your PhD?
I'm PhD student at the University of Zagreb. The department is in Department of the Materials, so even if I don't want, I cannot avoid that. So that's why I am very involved in these topics, especially those with energy efficiency into the building energy performance. So I need to know the structure, I need to know all the process, and then to proceed further with my other papers.
Okay. We wish you very success in your PhD. So now it's time to go to the next presentation.
Sorry, thank you.
The paper is titled Increased Durability for Concrete Structures Under Severe Conditions by Using
Julia's computer or no?
And
Better
here
stay.
the authors are from Pristina, from Milano, Athens, and the authors are Visar Kralani, Mohamed Ahmeti, Driton Vizeu, Liberato Ferrara,
I
Theodor
think it's okay.
Zikofakis. It's a little bit complicated, but the presenter will be Visar Kralani.
Okay.
Visar, the floor is yours.
Thank you very much. Thank you, dear Commission. Thank you, all the guests. It's a pleasure for me to present here. I'm used to present abroad and not in the region. So I'm very happy that now, and luckily we will have a good collaboration from the region. So to present here, and as you mentioned, I come from Kosovo, and from UBT University. In fact, we also will have a conference after exactly 1 month, and it's still open, the call, and co-sponsored from RILAB. So please, you are welcome to present your research paper also in Pristina after a month. And about the abstract and the presentation, yes, we are talking now a lot for durability, which is very important in fact. And before going to that field, I would like to present just an introduction of what we have done. Volume, can I? No? Okay, we'll have some music from Brazil. Maybe we'll like short review. This is a research activity. A lot of work in different types of concrete. As you can see, also self-healing, but also self-compacting concrete. And as you can see, then types of concrete that have been tested during time, based from conventional concrete, high-performance concrete with steel fibers, high-performance concrete with steel and natural fibers, which is related with the field of sustainability. And in fact, also we'll have the part of testing, different type of test. So to natural, we'll have single crack, to high-performance, multiple crack, again, bonding capacity, then 3-point bending test, 4-point bending test, tension, creep, shrinkage, UPV, etc., SAM characterization, microscopic study also. And normally, you need to complete it with a numerical simulation. To complete all, you have to evaluate the amount. And evaluate the amount, we need to produce some indexes. So different indexes have been calculated through time for self-healing, but to connect it with durability. So what's next and what is the challenge? The challenge is durability and cracks. This is our challenge. In fact, actually with all the environmental changes that we are having, it's the same challenge that we have with bears, because they are having cracks, which, as you know, what is the big problem now. But we also, engineers, are having problems with our cracks in concrete. So let's say we are trying to solve parallel issues. And when we think for cracks or for healing these cracks, in fact, here we can see we are not talking for a point. Here it's a video that shows through all the section we have the cracks. And what happened during time that we have done our studies, all the section can be also healed, which is not just a microscope, but it's also a video. Another point, it was to see if the crack is very big. It is possible these crystalline admixtures, to happen. In fact, if you do wet and dry cycles, it's a very fast procedure, let's say. After 15 days, we can see some of the crystals. If we continue the same after 30 days, you can see that the amount of crystals increased. And having this increasement of the crystals means a lot, because if we had a smaller crack, this means that these crystals can bridge the crack, which in a sense of durability is extremely important. We'll talk later on again for this topic. This image, it's a bit interesting, but to see the cover that cover also the bars, we understand what does it mean in sense of durability. And here we have listening different discussions these days also. Mr. Theodor, healing the crack will cover the steel. Reduction will have the reduction of permeability. Having the reduction of permeability will have the increase of the durability. If we arrive to the point to increase the durability, we are talking for sustainable structures. And having sustainable structures means that we'll increase the life cycle of the structures. So we are all related in the, we can also call green concrete in this sense if we arrive to this point. Turning, being in Skopje, it's always people a bit have a dynamic movement, unluckily because of the earthquake. And if we see the map of the hazard, European, we see that Balkans have a lot in common. One of the most important things that we have in common is the possibility to have earthquakes. So we are all together in this. This is a very interesting thing that makes us same. And unluckily, we have Macedonia, we have Kosovo, we have Albania, also Italy, but we are talking for this area. And the probability that we'll have earthquake exists, actually. But what is related durability with earthquakes? Someone can say, no, nothing. But in fact, we are seeing through the years that it's exactly directly related. We have two examples. We as a faculty, we helped Albania in 2019 in November. Luckily, it was 27 of November and not 28 when is the independence of Albania. That all Balkan people go to festivity there and will have a very high number of losses. It was a day before that happened. So what we have seen, we needed to evaluate. We were part of international community to evaluate the buildings. And you can see here the building, and we're not talking for the permission of construction, etc. But this was people from apartments said, our building is okay, we will continue to live. Then we said, let's see what is in these pillars. This is a column, the base column of the same building. And we took out this plate, and what you see, the concrete is just fell out. Having this, unfortunately, if you see the bars, even the bars in a very bad condition. So this building needs just another push, maybe, and people really, so we needed to put a red X in this building because still have to be studied if people had to enter. This is the worst, and when we talk for schools, it's more sensitive. To the school, it's a Turkey case, and we see here has been studied the quality of concrete, and if you see the quality of concrete, we can see cement paste also still pure there, not hydrated. But if we see then the reinforcement, you can see the reinforcement in which condition it is. So unluckily, the result is this. So it is related, earthquake, with durability, yes. Even if a statistical study that has been done, we see that the amount of cracking is one of the main factors that affect the durability. Then if we think the environment, Balkans have a very severe environment. We have XF, so the condition, the freeze-thaw cycles. We have XD, we put municipality, people ask from municipality, please put salt to the street, so concrete suffers. We have the XS, who have the seaside. We have XC, actually water in the concrete, and the result is this. What to do? So our field, we have to find solution. Van Bruegel, it's an important researcher, gave some studies from statistical data. In this graph, it's put performance versus time if you use normal quality, high quality, self-healing materials. If you use, so with colors, blue color, red color is normal concrete, lower quality. If we use that type of concrete, after 10 years, for sure we need to make a repair because of that quality. If we see in the cost, yes, it is in the start, in the beginning, it's lower cost, but after 15 years, we'll increase this cost. Okay, we go use higher quality of concrete. The first repair we'll have after 25 years old of the structure. In the cost, we have higher cost, but normally lower than the normal concrete. Now what to do? We have another type of concrete, which luckily is on studying and starting even to enter to the codes, is self-healing, concrete self-healing materials. How we expect, normally we don't discuss required strength, always. If we have these cracks and they recover by itself, we never will have that problem of having big cracks and repair, etc. Normally, if we want this, the cost will be higher than in both conditions. But in longer lifespan, it will be lower than the both type of concrete that we'll use. Okay, after this, let's say, introduction, I will enter to the case study, and together with the team, Professor Driton, Penetron team, and also Professor Liberato from Milano, it have been studied a case in the seaside of Valona, which is in Albania. I would like all to be there, yes. But I'm also measuring, I'll try to do faster. So in this time we are studying two types of building, one inside the sea and one in the lateral seaside. So we have XS, so hard, severe environment. Has been studied mixed design, inducing the crack, parallel laboratory testing, and discussion of experimental results, and also the conclusion. First, mixed design. When we plan the concrete, this is the key point. So we have building that will stay in the seaside constantly. We have the building that will be near the water of the sea. So we have here two types of concrete, C3037, C3545. This we'll call underwater concrete, lower strength, but important is to see PU3, and we'll call this later on. Then for the underground, we will have 3545 and PU2. In both cases have been used the crystalline admixture, and we'll see the result. This is a site exactly near the building that has been constructed. And we saw the year after, this is the result if you don't take measures into consideration. And then after 2 years, who knows in what condition it is. So we needed to take care. Challenges a lot, hot weather, severe environment, etc. And here it's a video just to understand how it's situation. And this is, it's not just severe environment, but during the winter, it's become even dynamic impact. So this is the building ongoing, retrofitting or strengthening, the type of how it has been done also. And here it's if it's work, and I guess it will work, thank you for the technical help. Then this is after 12 hours, the quality of concrete should needed to study. Then you can see that in the bottom of after 12 hours, the situation, you know, you need specialized people to go and test it. It's okay, 12 hours. So the quality of concrete normally should be very fast, right to the strength. Then these are conditioned due to the casting. So let's start from this, casting during the night. Also, the situation to create this environment is not easy. This is the plateau of the restaurant, and also this is the finishing if it's working. Just the planning of how it's okay, maybe not that one. Okay, never mind. So this is the morning when it's finishing the casting of the concrete, and in parallel, that just to remind, we were controlling also the quality of the concrete. An important issue is to induce the crack. So cracks happen, but we want to happen where we want. So to induce the crack in the walls, there has been put a system in the joints. In fact, I'll not lose too much time in detailing this, but this is the result of concentrating the crack. Okay, the crack has been concentrated. As we expected, cracks will happen. And we see that this was an early age crack. After a year, we see something, but if we do zoom here, after a year, we don't find anymore the crack. What happened? Not always the plan goes how you want. And some cracks again happened in some other sites. But we can see here that another help came. So in cracks uninduced, we had the product of crystalline admixtures that close them. What we want to see in different places happened like this. But the actual condition is that we have a very dry wall. It's not as the wall have been before. So how is the, now let's pass parallel test of the laboratory. Parallel test of the laboratory, as we know, the codes ask you, tell me the permeability test. Permeability test is using this machine, which has been done in parallel with controlling the site. And we can see here that for two types of concrete, the permeability is in this levels, 12, 30, 50. You know this type of test. To understand the permeability of the water, the European General Code doesn't give a measurement in amount, but the Slovenian one, yes. And Slovenian one, now remember PU3 and PU2. We have PU3 is the lowest permeability amount. So lowest permeability amount says if you have 20 plus 5, so 25, you're okay. In this case, for this we have 12, 13, 15, which is even 10 millimeters lower. So it's great for the concrete and for the bars. If we see the underground, we have PU2, 30 plus 10, 40 is permitted. We have 18, 18, 16. So a measurement with 17, so good for the structure. Strength, it's important because it's sensitive in that area. We have for 30, 37, we arrive to 43, so we are calm. For the higher strength concrete, 35, 45, it has been arrived until 51, so it's again, after 20 days, it's okay. Charts, this is just to show that it's a big amount of tests that has been done during time. It's not just one. So we have the chart of the results that are all of them completed. And then when you do permeability test, you do also splitting test. So the splitting test means the probability to have again cracks because of the low strength in tensile for concrete. But as we expected, the crystalline admixture improved even the tensile, not just the compression capacity. So we have 30-37 is 3.7 the tensile testing. From 35-45, 4.2 megapascal tensile capacity, so it's good. How is the actual, I've done faster than I thought. So it's, until now I'm 15 minutes. I'm measuring, I'm trying. If we are the same time, in 2 minutes I'll finish. Actual situation.
Spend your time.
I can finish in 1 minute.
Go to conclusion.
Yes, I go. So the actual situation is this. Okay, I'll pass this, but this is the situation. And the situation in the building is finished, and also you have a swimming pool in the middle, around parking. So it's a very complicated case, but people also enjoy it in the seaside. And the conclusions, strength have been completed in both cases, which is important for structures. Permeability, we saw we are lower than the requests, exactly in 2 types of concretes. We have longer cycles that we are ongoing, so until 1 month we'll test for permeability. We have created a tailored durability self-healing methodology, which can be used from everyone. It can be for other researchers also. This means that healing the cracks, covered steel will create a reduction of permeability, increasing durability and sustainable construction and increased life cycle. Just to show, these are from yesterday test, no one saw. It's permeability of cracked concrete. This is a result after 1 month in sweet water, so for lake case. We have the crystalline going out of this is the result. What we expected with saline water to don't have recover. Believe me, even negative result, it's good because it's no. We are having some new products that we still have to study. It's closing, it's strong, and for durability, again, it's good. Permeability is very strange. We need other researchers to explain. It's kind of insulation. After 1 month, water remains inside, in front of what happened in other cases. So we have to see, but important, it's dry. It's very dry, the result. And with this, I conclude, and I thank also Penetrum for the support, and all for you for having patience to listen until the end. Thank you very much.
Thank you, Lisa, for your interesting presentation and detailed investigation, which is very interesting. Due to the time, we have a short time just for one short question. Yes.
I have one question for the project in Vlora. What is the lifespan of the building that you showed, the restaurant with the swimming
The
pool?
lifespan
Predicted for
predicted. It's a normal building, so it's 50 years. It's not a strategic one. but with 50 years for sure it will arrive 20 years more for sure, 25 years.
So
Because
75 with
Sir,
this
yes,
75
yes.
you predict.
But because you know, Eurocode have strategic buildings, kind of bridges and other, and this is a normal bridge. No, sorry, normal building, normal construction. But the conditions are very severe. So the situation is very good because.
And how much?
Just another explanation. I received the photo, but I didn't put it. Still today, the underground is dry, even having a swimming pool there around.
Well, when was it built? When was the project finished?
This year have been completed.
Of course, it should be dry for such a short time.
Yeah, actually, in the first stage, to the early cracks, the buildings that have water have problems, usually at the early age. Later on, so we'll see. After some years, I'll present.
So, what would your prediction be in 50 years for the water permeability?
We should finish here with
We-
answers. We can continue.
We can continue later.
Yes, we have
Okay.
just 2 more presentations, so we should carry on.
We are here, we can explain the details. Thank you very much. Thank you. Thank you. Just close it.
The next paper is written by our colleague from Civil Engineering faculty from University of Belgrade.
Take it later.
The authors of the papers are Milica Stojković, Marina Aškradić, Aleksandar Radević, Aleksandar Savić,
Very
and
kind.
Emilija Zavić.
Thank you very much.
Certified wastewater treated sludge as partial replacement of cement in concrete composites. The paper will be presented by Aleksandar Savić. So Aleksandar, please come. The floor is yours.
Thank you, dear chair ladies, dear colleagues and friends, and both. It is great to be here together and to exchange all the good ideas and all the good thoughts and good emotions. So today we are going to see some results regarding this solidified wastewater treated sludge and the effects that we have in using it in some interesting applications. You see the team of authors. This team is developed by the fact that it is a laboratory investigation that was done at the laboratory at the Faculty of Civil Engineering, Belgrade. The first thing that we wanted to present to you is the fact that there is a lot of floods going on, and we see that very often in the news. These are only some of the pictures of some of the situations that have happened in Belgrade and in Serbia, and this is all due several reasons, one of which is the fact that we have this pavement that is not absorbing this water. Okay. As I have said, this is one of the effects that is studied at the faculty in the area of the broader project, which is given here. Not to make too much talk about the specific details, I want to just to point to you this use of pervious concrete in urban environment as a potential result. And the project is as illustrated here, something that is done in several faculties, not only in Belgrade, and is funded by the Fund for Science of Republic of Serbia program IDEA. Here we have a visual demonstration of such material. So we should see now the, yes, because this wasn't working as I expected.
Ovakvu površinu se ne samo infiltrira u podzemlje, nego se i dodatno i prečišćava.
We can do it once again.
Ovakvu površinu se ne samo infiltrira u podzemlje, nego se i dodatno i prečišćava. Otpad se u okviru ovog projekta integriše kroz upotrebu otpadnih materijala u građevinarstvu.
For materials. There was a broader talk and the lady was talking much, so I had to cut it for this presentation. So this is the material that was used as a byproduct in these pavements. So you have municipal wastewater that is treated, and you get wastewater sludge that is waste that you have to dispose somewhere, and because of that we did solidification and tried to use it. We used two types of this material. One is solidified sludge as is, and the another one is modified sludge, modified by these agents. So this is material characterization that give you the fact and the information about what is it consisted of, and where you can find it in the composites that we made. And this is a broad particle size distribution that is that can be seen here. And this material was used in mortars, mortar mixtures given up, and then porous concrete mixtures and lightweight porous concrete mixtures. Sadly, we didn't have the opportunity to give you the exact composition of the porous concrete mixtures and lightweight porous concrete mixtures because they are still developing in the Promobet factory. But this is what we could give you as main bullets about the material. I was thinking about giving these mechanical properties results done on mortars that you can't find in the paper, but was elsewhere presented, just to illustrate the trend of the decrease of the properties due to the amount of incorporation of this material. Therefore, we can conclude that this material usually decreases the mechanical properties, so we thought about how we could improve them, both on mortars and on porous pavements. Both porous concrete pavements were tested, but the aggregates were different. We had crushed aggregate in one and porous lightweight aggregate in other case. And these are the results that are presented in the paper, which give you the main idea of the main investigations that we have done in those three cases. Porous concrete, lightweight porous concrete, and mortar. And the trends are very similar to what we have seen on the slide before. One of the most interesting things is that not only having this porous pavement, porous concrete, was the idea, but also the filtration coefficient had to be finally set, because there was a problem if water was going through this concrete too fast. It had to be set to such value that the water stays for a while in the porous concrete, and at that point we have the positive effect of cleaning the wastewater. That is also one of the outcomes of this research that we were expected. Now, two conclusions. What is we all saw? What is the fact we all saw? That these products do have a negative effect in composites as mortars and concretes, but they are possible to use in them, and there is a possibility that we are developing more in the research to use it in rain-induced urban floods and improve that. Mathematically, when we calculate the trends, we have this effect on compressive strength, 19% for mortar drop in properties, 24 for porous concrete, and 46 for lightweight porous concrete, and also decrease in abrasion resistance that was tested on only on porous concrete materials. And also the modification of this solidified sludge was in fact a good idea to do because it made it better in these materials, and first results say that the improvement is almost twice. The behavior is almost twice better in mechanical properties than when we use only the normal solidified wastewater sludge. So that was all that I wanted to present today. Thank you.
Alexander, for respecting time slot.
Yeah.
I will add that in our investigation, it is, let's say, easy to find the way to use some materials which are good, but in opposite situation, it is a very big challenge. So this is a very big challenge, and I hope you will succeed in your challenge.
Thank you, dear professor.
We will have enough time for one question, please.
Okay. Thank you.
Okay, dear colleagues, now we are going with the last presentation for today, for this session. The paper is titled Bending Behavior of Cross Laminated Timber Panels Made from Locally Sourced Spruce Wood, and Nadia Simovic will present this paper. Co-authors Marija Todorović i Ivan Vičković.
Tako je, hvala. Evo, ja sam pripremila prezentaciju na srpskom, nadam se da to nije problem. Ja sam Nađa Simović, student doktorskih studija i asistent na Građevinskom fakultetu u Beogradu, za oni koji me ne znaju. I tema ovog rada je, kao što su rekli, ponašanje pri savijanju panela od unakrsno lameliranog drveta koje je napravljeno od lokalne smreke. I sad ovde je kratak sadržaj i neke stavke kroz koje ćemo proći, dakle nešto uvodno o radu, eksperimentalno ispitivanje i rezultati tog ispitivanja, numerička analiza kao i neki zaključci koji se mogu izvesti iz ovog rada. Za one koji nisu upoznati sa ovom materijom, CLT od Cross Laminated Timber ili ti unakrsno lamelirano drvo je inovativni pločasti proizvod na bazi drveta koji se dobija lepljenjem unakrsno postavljenih slojeva i to najčešće neparnog broja slojeva, dakle 3, 5 ili 7, koji se sastoji od drvenih dasaka, odnosno lamela, koje su najčešće debljine od 2 do 4 cm i širine od 6 do 30 cm i da bi se postigla dovoljna dužina panela, te daske se nastavljaju zupčastim spojevima. I sad zbog ovakve svoje forme i zbog dobrog ponašanja u ravni i izvan ravni, CLT paneli se koriste kao zidovi i međuspratne konstrukcije, što dalje vodi ka tome da se i neke srednje visoke ili visoke zgrade mogu praviti od drveta. Jedina mana ili jedna od mana CLT-a je što još uvek nije uvršten u standarde, ali postoji dosta i eksperimentalnog i numeričkog istraživanja na ovu temu, tako da se ide ka tome da se ova mana ukloni i tema ovog rada je jedno eksperimentalno i numeričko istraživanje na CLT panelima, tako da je ovaj eksperimentalni program u stvari obuhvatio između ostalog 5 uzoraka CLT panela od smrekinog drveta, klase čvrstoće C24. U pitanju su petoslojni paneli, tako da je svaki sloj debljine 3 cm i onda je ukupna debljina panela 15 cm, širine 48 cm i dužine 4 metra. I ovi paneli su ispitani u jednom zatvorenom čeličnom ramu, dakle izvršen je 4-point bending test, odnosno paneli sad statičkog sistema proste grede, raspona 3,8 metara su opterećeni sa 2 koncentrisane sile i opterećenje je naneseno pomoću hidrauličke panj prese i nivo opterećenja je meren pomoću dozne. Takođe mereni su i ugibi, pre svega u sredini, koji su ovi induktivni ugibomeri su postavljeni sa obe strane panela i po 2 ugibomera na dosloncima, čisto da bi se pratilo njihovo eventualno pomeranje. I takođe izmerene su i lokalne deformacije, odnosno dilatacije po visini, odnosno debljini panela pomoću mernih traka. Na osnovu sad ovog ispitivanja napravljene su krive, odnosno dijagram sila pomeranja za svih 5 uzoraka, gde se vidi da je ponašanje ovih panela skoro potpuno linearno elastično do trenutka loma i lom nastupa iznenada i to naravno u zategnutoj zoni, u zoni maksimalnog momenta i iniciran je na mestu defekata u drvetu, dakle na mestu čvorova ili eventualnih zupčastih spojeva tih lamela ukoliko su se nalazile u toj zategnutoj zoni. I ovaj lom je propraćen i određenim smičućim pukotinama i takođe nisu primećeni tragovi plastifikacije u pritisnutoj zoni. Na osnovu ovog ispitivanja takođe određen je i moment nosivosti na osnovu maksimalne sile koja se dobila na uzorcima i određena je takođe krutost na savijanje panela na osnovu nagiba krive linearnog dela od 0,1 do 0,4 od maksimalne sile i sad ovde u tabeli su prikazane sve ove vrednosti koje su proračunate. Takođe, izmerene su i dilatacije pomoću mernih traka za različite nivoje opterećenja kao i raspored dilatacija po visini panela gde se vidi da su one, da su dilatacije prilično linearne i da nema pomeranja neutralne ose. Takođe izvršena je i numerička analiza u programu RFM od Dlubal softvera koji se naravno zasniva na metodi konačnih elemenata i u sebi sadrži jedan određeni modul koji se koristi baš za dimenzionisanje laminatnih, odnosno slojevitih elemenata. I ono što treba prvo definisati jesu geometrija, uslovi oslanjanja ovih panela kao i opterećenje. I sad, pošto je ovaj program dizajniran pre svega za neku praktičnu primenu, dakle za dimenzionisanje prema graničnim stanjima nosivosti i upotrebljivosti, onda je opterećenje koje je naneto na ove panele u stvari eksploataciono koje iznosi negde od 20 do 30% od maksimalnog opterećenja koje smo dobili u eksperimentalnim rezultatima. Nakon ovoga, u ovom dodatnom modulu RF Laminate definiše se zapravo tip materijala koji se koristi i karakteristike svih panela. To su debljina, orijentacija, modul elastičnosti, modul smicanja i tako dalje. I na osnovu ovoga se generiše matrica krutosti i takođe u ovom modulu se bira da li postoji međusobno lepljenje bočnih strana lamela i da li postoji potpuno sprezanje između slojeva panela, što direktno utiče na raspored napona po debljini panela. Dalje se mogu odrediti presečne sile i pomeranja, odakle je formirana opet kriva sila pomeranja upoređena sa eksperimentalnim rezultatima gde se vidi da je poklapanje prilično dobro, razlika u nagibu krivih, odnosno u krutosti panela na savijanje je svega 4,5%. I opet u ovom dodatnom modulu uradi se analiza napona i deformacija, gde se ovde vidi sad raspored normalnog ismičućeg napona po debljini panela kao i njegova deformacija. I neki zaključci koji se mogu izvesti iz ovoga jeste da i ovo i eksperimentalno i numeričko istraživanje, odnosno ovi rezultati, jesu bitni i sa naučne i sa praktične tačke gledišta, s obzirom da CLT panele tek treba uvrstiti u standarde i postoji naznaka da će nova generacija Eurokoda sadržati tip proračuna i dimenzionisanje CLT panela. Iz eksperimentalnog ispitivanja, kao što sam rekla, dobija se da je ponašanje ovih panela do loma skoro potpuno linearno elastično. Iz rasporeda dilatacija se vidi da ravni preseci ostaju ravni posle deformacije i da nema klizanja između slojeva, a numerička analiza je pokazala da je moguće uraditi analizu napona i deformacija ovakvog tipa panela, odnosno slojevitih panela, i da je u stvari ta mala razlika između eksperimentalnih i numeričkih rezultata, ona zavisi od dosta faktora, pre svega od nekih ulaznih parametara i materijalnih karakteristika koje se definišu pri modeliranju ovih panela, tako da i ovaj program se može koristiti za ovakve tipove elemenata, ukoliko su naravno upotrebljene adekvatne materijalne karakteristike. I takođe bih naglasila da je ovo ispitivanje deo jednog većeg istraživanja koji je u sklopu naučnog projekta Substrate for CLT, koji je podržan od strane Fonda za nauku Republike Srbije i da ono obuhvata i statičko i dinamičko ispitivanje panela sa različitih dimenzija, sa različitim orijentacijom sloja tih panela i na nekim uzorcima je urađeno i ojačanje pomoću FRP šipki na bazi staklenih vlakana, tako da evo na ovim slikama možete vidjeti kako izgledaju sva ta ispitivanja i mislim da bi to bilo ukratko to. Hvala na pažnji.
Thank you, Nadia. This was very short and detailed presentation and very complex investigation. So now it's time for questions. Do you have any questions, please?
Hvala za zanimljivu prezentaciju. Mogu li na engleskom te izrazati?
Okay, yes.
How did you see with rolling shear? Because I think the dimensions were 5 meters.
4 meters.
4, okay. And the first one, and the second, what kind of glue did you use? Melamine or polyurethane-based glue? Because
Polyurethane,
polyurethane,
yes. And for the rolling shear, yeah, we had rolling shear in the transverse layers, but I mean, it's not that common for those, for this kind of CLT elements because they don't have enough length and enough width of the panel, and I think we had also panels with transverse layers from 45 degrees. Yes, so there are a lot of there is much more influence of rolling shear than on these panels.
Any other questions? If no, I would like just for sure, what are your plans for the future? Now you are making an investigation in bending experiment in bending. Do you plan to make a test for these panels in plane?
Well, probably not in plane. No, probably out of plane because I'm a PhD student and probably my PhD thesis will be out of plane bending, but probably from panels that have holes in it, so we will see.